We cut out a bunch of the parts 2 days ago, and yesterday I spent most of the day in here fitting up, tacking, and getting this table put together and halfway welded out. So today I'm going to finish welding it out and start working on the top rail assembly and the water bed portion of the build. But this is what we have so far. This is ended up being 12 foot long. That way we can have a 10-foot cut area. And I believe it's about 7'8" wide. Yeah, about 7'8". And that'll give us the cut area we need. But a big deal on this is square. Okay, so I spent a lot of time yesterday squaring, re-squaring, checking, tacking, squaring, tacking, welding, squaring, so on and so forth. Square is a big deal, remember that. So I got the bottom portion of this table really nice and square. I'm within a 1/16 from that corner to that corner and back this corner to this corner. So for a 7'8" wide by 12 foot long, I only have a 1/16 inch difference diagonally between the two. I'd say that's pretty good. You split that in half, so I'm square within a 32nd so far on this build. And I'd like to maintain that, especially once I get the cold rolled steel rails on here, because that's what the gantry is going to ride on, and that really has to be perfectly square. That way everything the table cuts out will be perfectly square. For customers, that's a big deal. So we'll just keep being really particular and detail oriented about this table build and make sure that it's square, so the rest of our parts that get cut out of it forever are going to be square. That's the beauty of this. We only have to set this square once, and from then on, as long as the computer cooperates and all that, everything else that we cut out on this table will be square, and I won't have to worry about it. So let's do some more welding, yeah? Welded all the way around, and this is the very last weld on the bottom portion of the frame. Woo! The lower portion of the table's done, and I'm moving on to the top portion of the table that's actually going to carry the gantry on it. And this is where I'm at right now. Here's the detail. This is the end of this tube, and then here's this other tube that's supposed to sit on top of it, and that's actually what holds the cold rolled steel. So you can see this is basically the end view that I got right there. Is that tube, and this piece of cold rolled right here sits on top of there. And these two are bolted together, but I believe this tube right here is welded down to the table. But I got a problem. There's no weld detail on here. Not a whole lot in the way of details on here. It tells me what size holes to drill and the intervals on the cold roll, but it doesn't, obviously I need to drill corresponding holes in this tube here, but I just want to, I'm going to look up some build threads online real quick and see what some other people have done and probably just copy that. But one interesting thing is, now that we have this table over here, you can see this tube is floating on here. So that means that our table actually has a camber to it. It's bowed a little bit, which in structural steel, that's actually a good thing because it's preloaded now. So under tension, once we put weight on it, it should settle into itself flat, hopefully. I just hope we have enough weight with the water table and whatever steel's on top of it, as well as the gantry is going to be moving in different positions. So I don't know if I can count that as really, I guess that'd be dynamic load. But hopefully we'll have enough static load to take that preload out of the table and get it to sit flush. Otherwise, we're going to have to do some cutting and re-welding to relieve some of the stress off this thing. But we'll wait till further down the line to decide on that. Here we are. I've got the cold rolled steel here drilled, and I tapped this tube underneath here, and I don't have it tacked down yet. I've just got these clamps on either end holding it, and I just want to show you guys all the hard work and double checking finally paid off here, because if we check this for square, see this. So I've got 14'2" and 13/16 corner to corner that way. Got all of this 12-foot reach here. And 14'2" and 13/16. So that means we are exactly square down to the 16th. 14'2", 13/16, and 14'2", 13/16. And that's what we are shooting for, is dead nuts, titties, square, which is I'm pretty excited about. So basically what I did is I saw another build thread where a guy, he welded this tube down first and then came back and drilled it on the table and tapped it on the table and then drilled these and bolted them down later. But I decided to go ahead and bolt these together first and create this assembly so this stays really nice and stiff and hopefully helps keep it straight lengthways down the table. And I have done some checking, and it looks like in the middle of this run here, it does bow out just the slightest bit. So what I'm going to do is I'm going to end up tacking each of these ends where I've got the clamp, and same thing in those corners right there. And then I'm going to start massaging this middle back and forth down the line to get myself totally perfectly straight. Because square is not going to do us much good if the whole carriage is wobbling down the run here. So a little more tedious work, but I think it's going to pay off in the end with a really nice finished product. I've got everything squared up here. These two rails are square. I got them the exact same distance across now, in between the two, all the way up and down the table. That took a little bit of finagling and tacking and beating and whatnot, but I got them. So now I'm welding them out. I got this one done over here on this side, and this one I've got started. And how I'm welding it is, you see I've got my little soapstone marks here laid out already on the steel, and what I'm doing is I'm sequencing the weld. So I'm jumping from this side to this side to this side to that side, and skipping one each time that I go. That way, you see here I got one, skip one, weld, and then over here on this side I've got that welded already. So following that pattern, I'm trying to keep this from rolling and warping as I heat each side. So instead of welding out this one side, which would be faster, that would roll the whole tube over this way because the heat would be trying to pull it over. So by skipping back and forth, you can keep this nice and straight all the way up and down, and keep it from warping too much. So let's go ahead and get this sucker welded out. Closing out another day here on the plasma build, and made some good progress today. Got the rest of the table welded out. Got the cold rolled steel rails drilled, tapped, mounted, and welded out. And the best part about it is all the trouble we went through to keep this thing square and true and level and aligned totally paid off. We are still square, dead nuts, not even a 16th out, and we have a little bit of travel somewhere between this cross rail right here and this very end right here. We grow 1/16 this way. So we start there, and then we get 1/16 wider as I come out to this end of the table. You know, I don't know what to do about the 16th. I'm gonna call it good. And for a, let's see here, how wide is this table? Just under 7'8", foot wide, 12-foot long table, built in a home shop, perfectly true, well, perfectly square, and only a 16th out. I mean, it just shows you don't really need all the fancy tools and special equipment. This is literally a 220 Hobart welder. You can get at Tractor Supply off the shelf, and a couple clamps, measuring tape, chop saw, drill press. I mean, these are pretty common garage shop tools, and I really think this is possible for anybody to do, build one of these tables. So I'm just kind of sharing like the process and how it goes, because so far it's been pretty simple and straightforward, exactly as advertised by the two companies that sell these complimentary kits. I'm really happy to be this far along. This is really 2 days worth of work and 1 night of cutting out on the chop saw. And the table portion is doneski. And next order of business tomorrow is going to be figuring out this water bed that sits on top of the table. Yeah, hopefully that stack of metal right there will turn into the water table portion. Here's one little trick with fabricating is it's not always the steps that you do. The steps are usually pretty easy to figure out. A lot of the times your efficiency and how well something turns out all comes down to the order of those steps that you take. So I've seen some people that take these side panels right here and weld them out first as one panel, and then they have both sides to stand up, and then they connect these two or these 3 cross members in between. But really the focus for me on this build was keeping this square. So I started with a square, you know, or a rectangle that I squared up first thing on the ground, and I leveled it out on the shims before I welded it. So it was totally level and totally square before it got welded out. And that made building the rest of the table on top of that, because it got built upside down here, that made building the rest of the table a lot easier, because I already had a perfectly square level surface to work off of. That's what all these little wood shims are all over the ground right here. That's what I was using to level every single piece that I had laid out down on the ground, because my concrete's not level, so I needed to create a level surface. So that's my recommendation, is start with this upside down with this top portion of the frame making a continuous loop. Obviously this is index back, and I messed this up. This should be in line with this cross member right here. There just was no dimension on the print, and I was just excited and decided to roll with it. But this will still totally support the water table that sits on top of here and transfer the load of the material over to this leg. It's about 3 inches off. Start with this portion sitting on the ground and level it all up with all these shims all around and get it nice and level, and then tack it and rack it to get it square, and then tack it some more and probably rack it some more, and then tack it some more, check it for square, and by then you should be pretty damn close to square. And from that point, all you have to do is weld it out and lay everything up on top, all these legs, these verticals here. Just lay all those down, lay your cross members out, and go ahead and build the second portion of this upside down, if that makes sense. And as you go, you just tack it, rack it plumb at this point, because now we're vertically working on these vertical supports. And already having a perfectly plumb square base makes this really easy. You can just use a square, a speed square, and pull everything square off of these base tubes here, and the whole thing comes together really, really smoothly, and you end up with perfectly square, perfectly aligned every part of the build, which is really important. So you guys are free to do as you please, but that's kind of my experience so far building this first one, and from about 5 years of ironworking in the field. Just trying to share some of my experience and knowledge here in the shop, because I think that's what being a maker is not just building things, but sharing how to build them, because there's lots of cool craftsmen out there, but to be a maker is a little bit different. You have to understand how to build things and how to share that knowledge, which is a whole new experience for me, and really exploring this medium of film to teach and share and connect with people. And I just really want to be a better fabricator, and I want to show people everything that I know in the hopes that they'll give it back to me. I know that sounds kind of selfish, but even more than that, YouTube has already taught me so much. Me and my wife call it YouTube University because you can literally learn anything that you want on the internet, and usually there's a free video on YouTube. And I haven't found any good build videos on these plasma tables yet, and I think they're getting more and more popular, especially as 3D printers and stuff take off. So I just wanted to make my simple contribution and share with you guys the process of how to build a plasma table, because if you're interested in doing it, it's totally achievable. I just saved my money for a couple years and piled it up and planned and moved across the country so I could give this a shot and build this thing. So I know that sounds like a lot, but it also sounds like it's totally doable because I did it. And I'm not anybody special, so I'm just a guy with a passion for metal fabrication and a lot of curiosity about the world. Anyways, thanks for checking out my video, and man, I'm excited for the next step. Let's see where this goes.